So good evening, everyone. Today is the week 9 session of the fluid flow operations. So here we will talk about the dimensional analysis part, non-dimensional, how to get the non-dimensional number with some of the methods. Okay, so let's get going. I hope my screen is visible, right? So first, go to the lecture part. Mostly I'll be explaining with examples in this session because this is a sort of session where there is nothing to like remember or something. Okay, so you have to get going with the formula. We have to solve the problems and then only you can understand it. Let's one recap first. So here includes the homogeneity of dimension, Rayleigh method of dimensional analysis, and Buckingham pi method of dimensional analysis. Okay. So basically, there are two methods to make this non-dimensional number. Okay, so why this is important? Because every time you can't get to understand you if suppose you have a very complex system, right? So you won't be able to explain it with analytical solutions all the time. Suppose you have some experimental results, but you are not able to do its simulation part or modeling part because that is difficult sometimes. You are not getting any analytical solutions, or you have to solve numerically, which is another set of equations. So sometimes what we do or what people do that they sometimes solve the problems with non-dimensional number because this non-dimensional number will help you to understand the system physically, like what is exactly happening, which force is dominating, which is not dominating. Okay, what are the physical significance of the system, what is the significance of that particular non-dimensional parameter, which will help you to get into the system in more depth to understand basically. Okay, so that's why non-dimensional analysis is an important part of it, and it will change from system to system. It might happen that whatever the example I have shown, you may have same sort of parameter, same sort of system, but what you are looking at, what is your objective, will be the sole parameter to decide that which variables you should take in your non-dimensional analysis. Okay, so it is not the same case for all. Depending on the objective of your system, objective of your problem, this set of parameters change. Okay, so this is the basic thing about the non-dimensional. How to do it? There are two methods to do it: Rayleigh method and the Buckingham pi method. Okay. So it is the same, it is the thing they have explained here that sometimes experiments cannot be possible to carry out on its full size of units, right? Where the experiments are carried out in dam, river, channels, or hydraulic machines such as turbines, large pumps. So every time you cannot do the experiment to get the full result, to get the full aspect of that understanding physics of that system, right? So for those cases, you need some non-dimensional analysis, non-dimensional number to get the basic understanding of the physics of the system. Okay. Dimensional analysis and dynamic similarities are useful in finding such non-dimensional factors. So one has to express the experimental results in terms of non-dimensional factors. To do that, we need non-dimensional number. Okay. Mm. So let's use, you read the use. So it is a branch of mathematics which deals with the dimensions of quantities It is useful to find whether an equation of any flow phenomenon is rational or not. Generally, dimensionally homogeneous equation is called rational equation. By dimensional analysis, the relationship between various physical quantities in an equation can be obtained. I think now you can relate what I have just told in the beginning, that why these parameters are important. Rational formulae for a flow phenomenon can be derived. It helps in making suitable smaller sized models in which experiments can be performed to predict the performance of the prototypes. Okay. So what are the basic fundamentals of it? So to assess or measure an unknown quantities, we must have acceptable unit. There may be different standard units would be required as per definition and convenience to assess the quantities, out of which a small number of basic quantities are to be considered as standard quantities, and they are expressed in terms of basic units. The basic quantities, as we all know, we have little bit done this Buckingham Pi theorem. If you remember in the first class or second class, I forgot. Check the videos, it has been there. So we have done some sort of Buckingham Pi theorem during the flow analysis, like how this kinetic energy term and how the Reynolds number has been derived. If you remember, so there we have done Buckingham Pi theorem. So if you remember, there I have told that we have basic three units, which are nothing but the mass, length, and time, right? So which are this mass? So here also you can write. So basic parameters or units, you can call it mass m, length L, and time T, and their corresponding parameter, their corresponding units is SI units or CJ units, whatever. So you have other parameters also, but these are the basic ones. All the others quantities such as area, volume, velocity, acceleration, force, energy, units of physical properties, etc., which can be expressed in terms of fundamental units, are called derived units and formed by multiplying or dividing fundamental units. So these are the primary fundamental units: mass, length, and time. Auxiliary, there are auxiliary, that means measurement of certain physical quantities in electrical, thermal, or illumination and elementary particle disciplines are also represented by fundamental units. So these are the auxiliary fundamental units, which are ampere, Kelvin, candela, and mole. And convenient fundamental unit, for a convenience, some engineers prefers to use quantity which is easier to measure instead of mass as fundamental quantity. It is mostly force. In this case, the system is represented by letters FLT instead of MLT. Okay. So these are the some important quantities with dimensions. Okay. So there are two methods. So if I read it from here, so first one is the Rayleigh method. A second one is the Buckingham's Pi method. So Rayleigh method is based on the fundamental principle of dimensional homogeneity of physical variables. And Buckingham Pi theorem relies on the identification of variables involved in a process. Further, a few of these have to be marked as repeating variables. Okay, so there is no concept of repeating variables in the Rayleigh method. So here he tells the dependent variable is identified and expressed as a product of all the independent variables raised to an unknown integer exponent. The repeating variables among themselves should not form a non-dimensional number. Okay. Then comes equating the indices of n fundamental dimensions of the variables involved, n independent equations are obtained. The fourth one is these n equations are solved to obtain the dimensionless groups. And in case of Buckingham pies, if a physical process has n variables and from these j are repeating variables, then there are n minus j independent non-dimensional numbers that can describe that process. Both Buckingham's, if we do more example, then you will understand the difference. If you have gone through the lecture, you have already understood, I think. So both Buckingham's method and Rayleigh's method of dimensional analysis determine only the relevant independent dimensionless parameters of a problem, but not the exact relationship between them. So here comes the if you take the example, it will be more here. So just let's get to the So it is a very common example. Okay. So it is doing that, let us consider a frictional resistance F. Okay. When a liquid is flowing through a pipe depends on the, I think this problem only I have given the example of, right? So this is the same problem we'll be doing with both Rayleigh method and the Buckingham pie method. Okay. Let us consider frictional resistance when a fluid is flowing through a pipe depends on the viscosity, density of the fluid, velocity of the flow, diameter of the pipe, and pipe surface roughness. Derive a rational equation for the pipe flow in terms of dimensionless groups by Rayleigh's method. So, why? First, we have to understand the parameters. So, this frictional resistance force F is dependent on all these independent variables. That means if you change, suppose a fluid is flowing, suppose water is flowing. So suppose water is flowing. Okay, this is water, and the second case, this is some sort of oil you can take, or suppose honey I am taking. Okay, so this has higher viscosity, higher density, right? So the way water will move, definitely the honey will not move in the same speed or same honey will not have the same viscosity or same density, right? And if you give, suppose I am giving 1 ml per minute flow rate, so how much water will cover the distance with this flow rate? Honey will not cover that distance. Do you agree with that? Right? You can visualize like how water flow and honey flow can be different. Yes. So that is what it is telling. So it depends on certain parameters. What are these parameters? So it depends on this force or frictional resistance, whatever it is, it depends on the certain parameters. So what are these parameters? So this is viscosity. First one is the viscosity. So if the viscosity of the fluid changes, the flow will change. It is also the density. If the density of the fluid changes, then it will not flow. Then comes the diameter of the pipe, right? D. If the diameter of the pipe changes, the flow resistance will change. If the velocity of the fluid flow changes, the resistance frictional force will change. Then comes the roughness factor. If one pipe is smooth and another pipe is very rough, then obviously the frictional resistance will change. So that is why these 5 parameters are taken to be independent variables, and This frictional force is completely dependent on these 5 independent variables, right? So based on your system, you are choosing, based on your system, based on your objective, you are choosing this factor. Okay. Suppose in your case there is another, there may be two fluids are going. Okay. So you have to take, you have to consider the surface tension also there, right? You have to consider the surface tension of the two fluids, or interfacial tension of the two fluids to consider it, right? So depending on your system, this parameter will keep varying. Okay. Now what they did, so these are the definition. So now the functional equation they are defining, taking a constant. So what is it? So that means I am doing Rayleigh, right? Rayleigh method. Rayleigh method of non-dimensional analysis. So then what is it? So F is proportional to, so we will have a proportionality constant C, and it will be mu to the power A, rho to the power B, D to the power C, V to the power D, and epsilon to the power E. So to make it in the same form, I should write V first, I think, right? Yeah. So you can write it either way, but just to keep it simple or comparable, I am taking V first, V to the power C, and here it will be capital D. This is the diameter, right? Yeah. Now we'll compare their unit. So now we will come to the comparing of the unit of each and every dependent variables and independent variables. So we will do it on your own. So what is F? F is a force, right? So force means what? If you remember Newton's law, what is? It is mass into acceleration. Mass is what? M, right? Mass is M. Then mass into acceleration. Acceleration means meter per second square. I am taking those basic parameters, right? Keeping it mass, length, and time only. Okay, I am not taking the auxiliary one. I am not taking the convenient one. So this is m L T to the power minus 2. C is a constant. Then comes mu, right? What is the unit of mu? It is the Pascal second. Then what is Pascal? Pascal is, so mu unit is, so first one F is m into A. From there it is coming. So mu is, if you remember, Pascal second, right? So Pascal is again force per area, right? So force is again m into A. So it is m L T to the power minus 2 by L square into T. What it is coming? It is coming as m L to the power minus 1 T to the power minus 1. So it will be m L to the power minus 1 T to the power minus 1 to the power A. So we are just representing each of them in the form of non-dimension, in the form of basic parameters to make it to get the non-dimensional number. Okay, rho, you know, it is very easy, mass per volume. So it is mass per volume means L to the power minus 3 to the power B. V is meter per second velocity. So it is L t to the power minus 1 to the power c. D is just diameter, so it is only length. L to the power d, and epsilon, so the unit of epsilon is also length, right? So it is also L to the power e, right? Mm. So it is also L to the power e. Now we are taking the constant, suppose this is a constant, so we can anyway neglect it, right? So now we are comparing all the power. What will be, now we are comparing each of the powers. So what it is coming? For m, it is 1. So if you compare, so m is to the power 1, right? Then it is m to the power a. But if we are taking it in the left side, so it is 1 minus a. It will be minus b. There is no other m, right? Equals to 0. Right? So 1 equals to a plus b. Okay. Similarly, for L, we have L is also 1. It is L to the power minus a, that means plus a. It is L to the power minus 3b, that means plus 3b. L to the power c means minus c, minus d, minus e equals to 0. Okay, all of them, right? And for t, it will be minus 2 minus a, that means it will be plus a, minus c, that will be plus c, equals to 0, right? Now we have to solve this. How do you solve? So now what we'll get? So from the first equation, what we are getting? We are getting that b equals to 1 minus a. So from the first equation we are getting, so from the first equation what we got? 1 minus a minus b equals to 0. That means b equals to 1 minus a. And from the third equation, this is the first equation, this is the third equation. So from third equation we can get that minus 2a plus c equals to 0. Minus 2 plus a plus c equals to 0. So what is c? C will be 2 minus a, right? And now if we put this b and c in the second equation, which was 1 plus a plus 3b minus c minus d minus e. So 1 plus a plus 3b minus c minus d minus e equals to 0. Is it right? Just check the second equation. So it is 1 plus a plus 3b minus c minus d minus e. Yeah, it is same. So now we are putting the value of b and c. Okay. So we are getting everything b, c, d at least in terms of a. How much we can simplify? We'll see. So 1 plus a, 3b means 3 minus 3a, okay. C means minus 2 minus a minus a plus minus minus plus a, okay, minus d minus e equals to 0. So what it is coming? So it is 1 plus 3, 4 minus 2 is 2. Then a minus 3a is minus 2a plus a is minus a. 2 minus a minus d minus e equals to 0. And then d equals to 2 minus a minus e, right? Uh, right? So you are getting this B, C and D. Now we will substitute back in the equation. So what was the equation? This one. If mu rho C V epsilon D epsilon. So F equals to F was C equals to mu to the power A rho to the power B V to the power C d to the power d and epsilon to the power e. Okay. So this is, now we are putting the values. So f will be c as it is the constant, mu will be a because a is a. So rho will be b. B expression was 1 minus a. C expression was 2 minus a. D expression was 2 minus a minus e, right? And epsilon to the power e. Okay. So because we don't have a, we are representing everything in terms of a and e. So we don't have anything left. Now what we'll do, we'll little bit will form, like we'll be eliminating some terms and we'll be just rearrange it. How do we rearrange? So here they are bringing it as f equals to, so rho to the power 1, right? So if it come here, it will be rho at the denominator. Rho, then v square, you can see, right? It is v square, then d square, right? Equals to c constant. Then what are the terms left? So you have to be very smart to get to, you have to understand the physics experimentally, that whether you are taking the right parameters, right group of parameters in that one form combination or not. Otherwise there is no point. Okay, so you have to do the experiment, or you have to have a good understanding of the system what you are taking to take this, to do this analysis. So now what is left? So rho is left, rho to the power minus a is left, right? Rho to the power minus a, v to the power minus a, t to the power minus a divided by, there is another thing is left, what it is, mu to the power a, and another two terms are left. If I bracket this, and there are another two terms left, what is, so d to the power minus e and epsilon to the power e, right? Now what we can write, f by rho v square d square equals to c into, excuse me, so it will be rho vd by mu to the power minus a, right? So mu to the power a can be written as mu to the power 1 by mu to the power minus a, right? Similarly, it will be epsilon by d to the power e. Now you are familiar with these two terms. Now you are getting something. So now what can we write? We just write it in the form of non-dimensional function of these two. So this f by rho v square d square equals to function of rho vd by mu to the power minus a, or you can write it in a function of rho vd by mu, that is nothing but your Re, and Reynolds number, that is the roughness factor. So it is nothing but the function of Re and roughness factor, right? So if you calculate all the parameters, basic units, you will get that this is one non-dimensional number, this is one non-dimensional number, and this is one non-dimensional number. Okay, so this is how you get three non-dimensional parameters from this Rayleigh method. Okay, so in the next lecture also it is some recapping, and then we'll do the Buckingham pi theorem for the same system. So you know these things, just we have gone through. Okay, so let's get to the examples directly. So now same system. So here what we have to define, we have to define the relevant parameters, that what are the total numbers of parameters. So as you can know, there are 5 independent variables. So for Buckingham pi theorems, or you can just write in the next slide. Of dimensional analysis. Okay, so here the parameters are same, right? So f is a function of mu, rho, velocity, diameter, and roughness factor, right? And total number of variables is 6, right? 5 independent variables and 1 dependent variables. These are independent, and this one is dependent variables, right? And what are the basic parameters J? So basic parameters we know there are 3, M, L, T. So it is 3. So now number of dimensional parameters will be 3. So this is 6 minus 3 will be 3, right? When it comes to, like, if the total number of parameters is 3 and J is also 3, so that means 3 minus 3 equals to 0, which means your system should not have any non-dimensional number, but that is not true, right? It cannot be happen. So that time we have to take J as 2. So we can take 3 minus 2 1, or 3 minus 1 equals to 2 parameters depending on the system. So this is the number. So you have 3 number of dimensionless parameters. Okay. non-dimensional groups. Now what is shown? So now we have to choose 3 dimensionally independent repeating variables. Okay. So what are these? So as j equals to 3, we have to choose 3 dimensionally independent repeating variables. But here is a note. Now what is note? If n equals to j, that means if the number of variables is 3, j is also 3. So you have to consider, so that case it will be n minus j equals to 0. That is not, no dimensional group will be formed, which is not possible. Therefore in this case you should be taking j as 2. Okay. So here j should be 2. 3 minus 1 equals to 2. In this case, you have to pick 2 repeating variables. Okay. So here you have to pick 2 repeating variables. In this case, it is 3 repeating variables. So what are the repeating variables for this system? It is the fluid property, from flow characteristic, and from geometric characteristics. So from the flow property, it will be rho. You can take mu also, but we are taking rho. From the fluid characteristics, fluid point of view, it will be, or flow characteristics, it will be V, and the geometric characteristics is D. Fluid characteristics or flow characteristics, it will be velocity, and for geometrical characteristics, it will be D, diameter. Right? So these are 3 repeating variables. So now what are the else variables that is there? So now we can take all the rest of the variables as 1. So now we have 3-dimensional numbers. So pi1 will be repeating variables like rho to the power a1, v to the power b1, d to the power c1 into f, right? This is one of the variables. Pi2 will be rho to the power a2, v to the power b2, d to the power c2 into mu. This is another independent variable. And pi3 will be rho to the power a3, v to the power b3, and d to the power c3, and epsilon. It is a roughness factor, right? Now we have to do the same thing. We have to take individual parameters, right? So what it is coming? So for every group of non-dimensional parameter, we have to do the comparison between the powers, right? So pi1 will be first one is the rho, repeating variables, right? Rho is m l to the power minus 3 to the power a1 into l t to the power minus 1 to the power b1, then d is l to the power c1, and then there is m l t to the power minus 2, which is f. Now if we compare this, right, Pi 1, it will be like it is non-dimensional, that means it doesn't have any unit. So m to the power 0, l to the power 0, t to the power 0. So we are comparing all. For m, it will be like a1 plus 1 equals to 0, right? Did you get it? So m has a1 to the power in the right hand side and n to the power 1. So a1 plus 1, and in the left hand side is 0. So I have written it opposite, but I know you can get it. So now we have got that a equals to -1. Similarly, for L, what is? So it is -3a1 plus b1 plus c1 plus 1 equals to 0. So we only know. So what we know, we know a1 value. A1 is -1. So it will be 3 plus b1 plus c1 plus 1 equals to 0. It means b1 plus c1 equals to -4. And for t, if we compare, it will be minus b1 minus 2 equals to 0. So also now b have a value. So b1 will be -2, right? Now if you put this -2 here, so it will be minus. So here it can come -2 plus c1 equals to -4. So c1 will be -4 plus 2 -2. So this is the value of a1, this is the value of b1, and this is the value of c1, right? Now we can put this. So now your pi 1 will be, right? So it is f was there. First one was rho to the power a1, that means rho to the power -1. That is why I have written in the denominator. Then there is v, right? There is v. So v to the power b1. It is my v square. So if it is denominator, it will be v square. Then it will be d square. Similarly, right? So this is your first dimensional number, which we also have got from the Rayleigh method. Then comes the pi 2. Similarly, if you do it, I am not doing it because it is explained, or else I am doing it. Okay, let me do it. So in the F2, what was there? Pi 2 is this expression. So we are taking the units of them. So it is m0, m to the power 0, l to the power 0, t to the power 0 equals to rho will be ml to the power -3a1. Then comes L t to the power -1 to the power b1. Then for diameter it is L to the power c1. Then for mu we have defined earlier m L to the power -1 t to the power -1. Now for m it is 0 equals to a1 plus 1. So that means a1 will be -1. For L it will be 0 equals to -3a1 plus b1 -1 equals to, so that is, so I know the value of -1, so it will be -3 into -1, it will be 3 plus b1 -1 equals to 0. That means b1 will be -3 -3 plus 3 -1 2, that will be -2, right? So here if you find Am I missing something? Okay. Sorry. It is not 1, right? It is 2. B2, C2, like that. So it is A2. There is another term that is plus C2. I have missed this. So A2, B2 and C2. So now what it is there? So this is wrong completely. So in the next slide we can do. So for L it is coming as minus 3A2 plus B2 plus C2 minus 1 equals to 0. So it is coming 3 plus B2 plus C2 minus 1 equals to 0. So B2 plus C2 is coming as 3 minus 1, 2 minus 2. For T, it will be similarly minus B2 and minus 1, right? So for T will be minus B2 minus 1 equals to 0. That is B2 will be minus 1. And now you put this value here. So minus 1 plus C2 equals to minus 2. So C2 will be minus 2 plus 1, that is minus 1. So what are you getting? So for pi 2, right, you are getting mu, then rho to the power minus 1, v to the power minus 1, d to the power minus 1. So what it is? It is rho v d by mu to the power minus 1. Basically, inverse of Reynolds number, right? Sorry. Yes. No, I think, yeah, it is 1 only. Because I have written in the denominator already. So it is mu by rho Vd. That means rho Vd by mu minus 1. So r to the power minus 1. And pi 3, similarly, if you solve it, you will get pi 3 as epsilon by d. I am not doing it. So I can explain it from here. So similarly here, so if you compare, A3 will come 0, B3 will come 0, and C3 will come as minus 1. So it is nothing but the epsilon by d. Okay. So now if you got the same thing, right? So F by rho Vd square, rho V square d square equals to F into rho Vd by mu into epsilon by d, right? It is the same thing. So there it has some other examples. Okay, just go through it. So here it has n is 3. So it has 3 variables total. Delta P, sigma and R. So J is also 3, so it will be 0, right? So in this case, we should take J as 2, right? 3 minus 1, 2. Or in this case, for this system particular, we have to take J as 2. So it will be, therefore 3 minus 2 equals to 1. That one number of dimensional groups are obtained. So there will be only one number of dimensional groups, and and repeating variable will be 3 minus 1, 2. That is sigma and r. So that is how they have solved this. The last lecture, it is all about the similarity between two systems. Okay. Similitude. It is called similitude. So similitude is a concept applicable to the testing of engineering models. In order to have complete idea about the flow device, it is very essential that the model should represent its prototype completely and fully in all aspects. Suppose you are making a hydraulic pump in lab scale. Okay, how it will flow or how it will behave in a real system. So we have to scale up this model with similar proportion, right? So the similarity between the prototype and its scale model is known as hydraulic similitude. Overall, the conditions that a model of a phenomenon reproduces all aspects of behavior of the prototypes represented by it are known as conditions of similitude. Okay. So depending upon that, this similarity is this lecture is done. Now we'll do some problems. So this is how the similitude. So it has the lab scale product. This is the large scale product. So L by model and L by prototype will be, it has a particular ratio. Okay. Similarly, both the velocity, both the acceleration, discharge can have this. Okay. So this is the Reynolds number also have the similitude. So now let's jump into the question answer section so that you can understand. So force is the primary fundamental unit, auxiliary fundamental unit, and the convenient fundamental unit. So primary one, you know, it is MLT. We have just gone through MLT. Auxiliary comes the theta, the mole, candela kind, and convenient has the F, force. So it is the convenient fundamental unit. The dimension of surface tension. Okay. So dimension of surface tension is so how much force one has to apply to per unit length to bring a molecule from its bulk to its interface. This is the definition of surface tension. So if I can write, definition is how much force per unit length one has to apply to bring a molecule from its bulk to interface. So that is so it is force per unit length, F by L. So force is ml t to the power minus 2, mass into acceleration, L is length is L. So it is m t to the power minus 2. Option A. Okay. Next. If there are n variables, in a dimensionally homogeneous equation, and if these variables contain m primary dimensions, then the variables can be grouped into how many non-dimensional groups? So it is easy. It is the Buckingham pi theorem, right? It is n minus m. So it is option B. Next, velocity of sound C varies with pressure and density. Using dimensional analysis, is it possible to relate the quantities as C equals to constant into under root of P by rho? Yes, it is possible because if you do, C is the sound velocity. Velocity means L t to the power minus 1. And now we have P by rho. P by rho is pressure. Pressure is force per unit area. Force is m L t to the power minus 2 by L square. That is again L to the power minus 2. This is pressure. And rho is kg per centimeter cube or meter cube. M L to the power minus 3. What it is coming? So it is L to the power L square, right? L square t to the power minus 2, right? Now if we take the root under of P by rho, it is L t to the power minus 1, which is similar to the velocity, right? So using dimension analysis, is it possible to relate these two particles, these two properties? Next, the dimension of kinematic viscosity. So kinematic viscosity is mu by rho, dynamic viscosity by density. So mu is Pascal second. So we have just seen that its unit is m L to the power minus 1 t to the power minus 1 by m L t to the power minus 3. So m will cancel out. It will be L 3 minus L square by t to the power minus 1. It is the meter square per second. So it is option B. Okay. Next, in Buckingham's method, the dimensionally independent repeating variables generally present fluid property and geometric characteristics and fluid characteristics. So it is along with the fluid property, it is both the geometric characteristics and fluid characteristics, both A and B. Next, the drag d of a sphere is influenced by the diameter of sphere, the flow velocity, fluid density and fluid viscosity, both, right? So drag force is F. So suppose there is a fluid is going and there is inside there is a particle. So it will obviously depend on its diameter of the sphere, then the flow velocity, then fluid density and fluid viscosity, right? So it is both A and B. Option C. Okay. Next. Brinkman number is often used to describe flows of organic and viscous fluids. It defines the ratio of viscous dissipation to heat conduction in fluids. It is a combination of flow viscosity, velocity, thermal conduction and fluid temperature. What should be the derivation of Brinkman number, which is proportional to viscosity? So it is a viscous dissipation to heat conduction, right? So viscous dissipation is represented at mu v square, and this heat conduction defined as K into T, right? So it is option A. Buckingham's method and Rayleigh's method of dimensional analysis determine only relevant independent dimensionless parameter. Exact relationship between them, not exact relationship between them, may or may not be exact. Problem specific, none of the above. So it is not exact relationship between them. It will talk about the parameter, the presence of that parameter, but it will not take that how, like what is the exact parameter. Okay. Next. Pressure difference across a soap bubble is related to the radius of curvature of the soap bubble. I think the derivation I have done in the any of the earlier sessions. So pressure difference delta P is for soap bubble. It is because soap bubble has two curvature, so it is 1 by sigma into 2 by R1 R plus 2 by R. So it is 4, sorry, sigma is proportional, 4 sigma by R, right? So pressure difference across the soap bubble related to the radius of curvature of the soap bubble. It is inversely proportional. Next, auxiliary fundamental unit of measurement of magnitude of light illumination is candela. Radian is not. Radian is the angle. In case of geometric similarity, the model and the prototype should have the same shape but different in size, the same ratio of all corresponding lengths but different in included angles, both A and B, none of the above. Geometric similarity means that all corresponding linear dimension has same ratio. That means the same shape should be there but in different size. So suppose this is the smaller version of a product, so this has to be the bigger version of the product. The angle also should be included. This is option A. So kinematic similarity is the similarity in shape, similarity in motion, similarity in forces. Kinematic similarity means it talks about the how fast a system progresses. It is always related to the motion. Next, Reynolds number Inertial force to viscous force is the same in both the model and prototype systems. It is classified as dynamic similarity. Okay, it is classified as dynamic similarity. It is not geometric similarity, it is dynamic similarity. Next, in case of supersonic flow, the value of Mach number is m greater than 1. If m is less than 1, so that is subsonic. M greater than is supersonic. The Froude number is the ratio of inertial force to gravity force. So this is your Froude number. If you have an expression of Froude number, you can see from here. Yes, it is inertial force, that is rho u square rho u square L square by rho L cube G, which is the gravity force. That means rho L cube is the m into G acceleration, gravitational acceleration. So it is u square by GL. This is your Froude number. Inertial force u square by GL. Next, considering a system wherein multiple layers of fluids, immiscible fluids, are in contact with one another, which of the following dimensionless numbers is most relevant towards defining the flow condition? For immiscible layers, it will be the Weber numbers. Why? Because Weber number is a ratio of inertial force to surface tension force. Okay. So when a moving liquid has its face in contact with another fluid which is immiscible or a solid, the inertia and surface tension both are important. So forces are important. So it is inertial force to surface tension ratio. So the root is the square root of this value will be the Weber number. So it is the root under inertial force by surface tension. So it is Weber number. Inertia force by surface tension. To find a drag in an airplane which is moving at 275 mph meter per hour, is it possible to test a 1:25 scale model in a subsonic wind tunnel at the same pressure and temperature? To achieve the dynamic similarity, at the same pressure and temperature, the velocity in the model would have to be 25 times higher to maintain the same Reynolds number, likely exceeding the subsonic limits or practical tunnel capacities, right? So if your model is in suppose 1 and it has to be in the 25 times higher the model velocity, the actual velocity, then it will be higher than the subsonic velocity. So it is not possible. This answer is no. The losses in a pipe junction for a 1.3 meter diameter pipe system carrying gas, mu is given, V is given, are to be determined by testing a model by flowing water. The laboratory has a water capacity. Calculate the diameter of the model. The viscosity of water at 40 degree is given. Okay. So Reynolds number we can calculate for the model system and the prototype system, right? Kinematic similarity. Sorry, dynamic similarity. So RE prototype versus RE model. So it says the losses in a pipe junction for a 1.3 meter diameter pipe system carrying gas and mu V is this are to be determined by testing a model by flowing at 40 degrees centigrade. The laboratory has a water capacity of 80 liter per second. Calculate the diameter of the model. First, so it will be Reynolds number equality, right? Dynamic similarity. So it will be rho Vd by mu at P equals to rho Vd by mu at model. So for rho we know D needs to be calculated for model. Mu we know for both the cases. V we will. V is also known, right? Yeah. So for the actual laboratory case, Q is written as Q is given as 80 liter per second. So this for the model case Vm will be Q by Am, right? And this will be Q by pi d m square by 4. So if you put the value 4 into 80 liter per second divided by pi dm, diameter of the pipe is 1.3 meter square. How much it is coming? So it is 60.3 meter per second. 60.3 meter per second. Now rho is given, rho is 40 for both the cases because water is only flowing. We can cancel rho P and rho M. V is different. V model is 28 and now it is 60.3. So rho cancelled out. So rho P and rho M will cancel out. So Vp is 28. dPe just okay. So dm we are calculating, right? So it is not 1.3, it is the pipe diameter. It is rather dp. Sorry. So this is the wrong part. Don't do this. Yeah. So let me write first. Rho p is same. V Vp is 28. Dp is 1.3, and mu p is given, which is 2 into 10 to the power minus 4. 2 into 10 to the power minus 4 equals to rho m is given into this things we need to calculate Vm, and now the expression is 4q by pi d square dm square into dm we need to calculate, and the 40 at 40 degrees centigrade the water viscosity 6.51 into 10 to the power minus 4. So it is 6.51 into 10 to the power minus 4. Then we know so rho p and rho a, because both are waters which can be cancelled out. So now we have to calculate. So one dm will be there. So dm is nothing but, so 10 to the power minus 4 and 10 to the power minus 4 will cancel out. So dm will finally, if you rearrange, and dm will get as 4 into 80 or 80 liter per second, means you can change it to 0.08 10 to the minus 3 meter cube per second, right? It is 0.08 meter cube per second. So it will be 4 into 0.08 into 2 divided by 3.14 into 6.51 into 28 into 1.3. Somewhere I have done the calculation mistake probably. Hmm. Yes. Hmm. Just a minute, I have done some calculation mistake. I'm not able to figure out. It is rho p, rho m. Okay, so rho P and rho M are not same, obviously. For obvious reasons. I have missed this part. So rho at the pipe system carrying, it is 40 kg per meter cube, but at 40 degrees centigrade, the density will also change, right? So what will be the density at 40 degrees centigrade of water? It is 992.2 kg per meter cube. Okay. So now it will be like 40 and it will be like 992.2. So if you do this, it will come as 0.021 meter. So it is 21 millimeter. Okay, so I think we have the answer here. It is 21 millimeter. Next. So water at 15 degrees centigrade flows at 3.65 meter per second in a 0.15 meter pipe. Okay. Then at what velocity must medium fuel oil at 32 degrees centigrade? It has V flow. V means the new flow in a 0.07 meter pipe for the two flows to be dynamically similar. To be dynamically similar, the RE of water and RE of oil should be same. So rho will be similar. Okay. Then rho VD. Okay, rho would not be similar, obviously. Both are water and oil. Okay. So rho VD by mu for water and rho VD mu by oil. So here we know the kinematic parameter, right? So we can also write so VD by nu because for oil nu is given, right? So for oil velocity VO, it will be V of W d W by d of O and W by IO, right? So VW is given as 3.65 meter per second, it is water. Then dW by it will be 0.15 by 0.07 and the given viscosity will be dynamically similar, right? So it will be, let's calculate. Where it is? Okay, just a minute. So at 50 degrees centigrade, water kinematic viscosity is 1.14. It is the oil viscosity is given as 2.96 into 10 to the power minus 6, and this water viscosity is given as 1.14 into 10 to the power minus 6. So it is coming as 3.65 into 0.15 into 2.96 divided by 0.07 into 1.14. It is coming as 20.3 meter per second, which is close to this option D. Okay. Okay. Next question. We'll do some more questions around this. So the first question is, according to Buckingham Pi theorem, if a physical process involves n variables and j fundamental dimensions, how many independent dimensionless groups can be formed? So it is very common question. So it is nothing but n by n minus j. Next, which dimensionless number is defined as the ratio of inertial force to viscous force? So it is, we have been doing this since the beginning of the class, nothing but the Reynolds number. Next, what is a rational equation in the context of dimensional analysis? So it is a dimensionally homogeneous equations where both sides have the same dimensions. Okay, where both sides have the same dimension. This is called rational equation, and that is how we can calculate the dimensionless number. It is defined already. When performing model testing for a ship's wave resistance where gravity is the primary force, which similarity law is most critical? So when gravity effect is there, so obviously Froude similarity will be most critical, because Froude number is the inertial force per gravitational force. Inertial force by gravitational force. Next, we come to the similitude problem. What it is? So it is said that 1 by 10 scale model of a flow device is tested with water to determine the pressure drop in a prototype that conveys a different liquid density. Okay, this is the prototype, different liquid. The prototype velocity is this. Find the required model velocity for dynamic similarity. Kinematic viscosity is given. So dynamic similarity means Reynolds number will be similar for prototype and model. So as this is represented in the terms of kinematic viscosity, we can say that we can write like V d Vp dP by nu P equals to Vm dm by nu m. What it is to be find? Find the required model velocity, right? So Vp is given as 4, right? dp is given as 1. Lp by Lm ratio is 1 by 10. So I am taking it as 1. dp by dm ratio, that means 1 by 10 scale model, right? So it is 1. And nu p we don't know. What we know is the rho p and mu p. So we can write it as 864. Mu p is 0.0019. Equals to Vm, we need to calculate. Tm is known as 10 and nu m is 1.02 into 10 to the power minus 6. So now Vm will be 4 into 864 by 0.0019 into 1.02 into 10 to the power minus 6 by 10. So it will be so this one is for the prototype and this one is for the model, right? So it will be so prototype ratio is prototype diameter versus model diameter is 1 by 10, right? That means model diameter is 10 times of prototype diameter, right? So it is 10. Here it will be 10, here it will be 1. So model will have to come. So the thing is, prototype, I am saying it is the laboratory scale, and model means I talked about the industry scale. So this is, you have to understand this, okay? So Vm is now coming as 18.55 meter per second. Okay, answer. Next question. So if this ratio you have written it wrong, then the result will come wrong. Okay. So derive a functional relationship for frictional resistance of a liquid flowing through a pipe which depends on the viscosity, density, velocity, diameter, and roughness. I think we have done this just now with the Rayleigh method. Okay, so I'm not doing it now. So this is I am writing as done. Okay, in this session only we have done it. So now a submarine is modeled at 1/40th scale. The prototype operates in seawater at some velocity. The model is tested in fresh water. Okay, if the force measured on the model is Fm, find the ratio of the power required for the prototype to the force on the model. So again for the dynamic similarity, so for dynamic similarity, we can say that RE model is equals to RE prototype. So it is rho m Vm L dm divided by mu m equals to rho p Vp dp equals by mu p, right? So we have to calculate first the model velocity. The submarine is modeled at 1/40th scale. Okay, so you need to calculate the model velocity first to know the model pressure, right? So model velocity Vm will be Vp, okay, into rho p by rho m into dp by dm and mu m by mu p. So what it is, Vp is given at model prototype velocity is 5, right? Prototype means the lab scale one is 5. Rho p in tested in seawater, it is rho p is 1028, and for fresh water, for model fresh water it is 998, into dp is like diameter for the prototype is uh like model is 1/40th of the prototype. So it is dp by dm is 40, and mu m is 1.1 into 10 to the power minus 3. So it will cancel out, divided by 1.88 into 10 to the power minus 3. So it is coming as calculate yourself. I am doing also. So it is coming as 109.5 meter per second model velocity. Next, we have to calculate the uh, uh, find the ratio of the power required for the prototype to the force on the model. So we have similarity of pressure coefficient, which is F by rho v square d square at, or Fp rho p vp square dp square equals to, for prototype, Fm rho m vm square dm square, right? So this Fp will be Fm we don't need to calculate Fm. Fm into rho p by rho m Vp by into Vp by Vms whole square and dP by dMA whole square. Okay, this is your Fp. Also, power force for the prototype means Pp equals to Fp into Vp, right? So we have the question was about the power required for the prototype to the force on the model. So that is the Pp by Fm ratio, right? So it will be Fp into Vp by, so it will be Fp into Vp, right? So Fp we know, Fp is this, into Vp, there is another Vp. So Fm will be this, so it is rho p by rho m whole square, that is rho p is 1028 by rho m is 998 into Vp, Vp is given 5, this is 109.5 whole square into 40 square into, there is another Vp from this, so it is equals to 17.5. 17.18 meter per second. Okay, from the unit itself you can see, right? This is the similitude expression. Next question. I think this is also done. That consider a soap bubble where the internal pressure difference depends only on the surface tension and bubble radius. Use the Buckingham pi method to given n equals to 3 and j equals to 2 fundamental dimensions. So here delta P is a function of sigma into R, right? So n equals to 3 also, j equals to 3 also. So it can't happen. So we have to take j equals to 2. That means dimensionless number will be 3 minus 2 equals to 1. And it has independent variable will be 2. Okay, so pi will be, so which has fluid property. Fluid property, it will be surface tension sigma to the power a, and fluid characteristics is not there, so it is geometric characteristics just the r to the power b into delta p. So now if you summarize it from the dimensional number perspective, so it will be m to the power 0, l to the power 0, t to the power 0, sigma to the power a. Sigma is, like we have defined it, f by l, right? M to the power minus 2 to the power a, then l to the power b, then pressure is force per unit square. So m l to the power minus 1, t to the power minus 2. So if you compare m, it will come as 0 equals to a minus 1, that means a equals to 1. A plus 1, sorry, a means minus 1, sorry. For L it is 0 equals to b minus 1, that is b equals to 1. And for if you similar comparing t, it will be 0 equals to minus 2a minus 2, that means a equals to minus 1, right? Which is coming already. So I've got a and b, you need not to do t, just to cross check you can do. So it is coming as dimensional number pi, which is delta p, right? Sigma to the power, so this will be sigma, right? And it will be r. So this is your non-dimensional number from Buckingham pi theorem, right? Next, the drag force on a sphere is influenced by its diameter, velocity, fluid density, and viscosity. Derive the dimensionless number. This also has been done in the equation, but still I can do it. The last we have done with Buckingham pi theorem, right? So now we can do it. So d is a function of diameter, velocity, density, and viscosity, right? So you can done with Rayleigh method. So what will come? Rayleigh method will be t to the power a mu to u to the power, sorry, u to the power b rho to the power c mu to the power d. So drag force, it is a force, it will be m L T to the power minus 2 then L to the power A, Lt to the power minus 1 to the power B, M L to the power minus 3 to the power C, and it will be M L to the power minus 1 T to the power minus 1 to the power D. So now if you compare, for M it will be 1 equals to C plus D, right? So from C what you can calculate? C will be 1 minus D, right? For L it will be 1 equals to B minus 3C. So for L it will be 1 equals to A plus B minus 3C and minus D, right? So only we know is a value of C. So 1 will be A plus B minus C we know is as 1 minus D, like 3 plus 3D, right? So if you put minus 3 plus 3D minus D, right? So it is 1 plus 3, that is 4, equals to A plus B plus 2D, right? If you compare T, it will coming as minus 2 equals to minus B and minus D, right? So now you have a expression in terms of B, right? So B will be B minus 2, right? No, B will be 2 minus D, sorry, B will be 2 minus D. So if you put that B here, or in the first case, what was combination? 1 minus C equals to 1 minus D, right? Yeah. So if you put B in this equation, so 4 equals to A plus 2 minus D plus 2D, that means 2 equals to A plus D, right? So A will be 2 minus D. So A is also 2 minus D, B is also 2 minus D, and C has come as 1 minus D, right? So everything we got in number of, in the expression of D. So now what is the expression? It is drag force is C into D to the power A, that is, what was it? D to the power A, right? U to the power B, rho to the power C, and mu to the power D. So D to the power A means D to the power 2 minus D, then U to the power also 2 minus D, then rho to the power 1 minus D, then mu to the power D, right? So now what if you can find C rho U square D square, right? This is one term you can define, and another one is mu divided by rho U D, right? All to the power D. right? So what it is coming? D by rho u square d square equals to C of or F of C into mu rho u d by to the power d. So now you can say that it is this d into rho u square d square equals to F of mu rho u d, which is nothing but the inverse of, or you can write it as function of rho u d by mu, right? So function of Reynolds number. So this is here from Rayleigh theorem. Okay, next. Power required to drive a centrifugal pump depends on the fluid density and the impeller diameter. Power required to drive a centrifugal pump depends on the fluid density, the impeller diameter, the rotational speed, and the discharge rate, and the viscosity. The dimensional relationship using the Buckingham Pi theorem. So what it is there? So P is a function of rho, right? Density, diameter, rotational speed, flow rate, viscosity. Total N is 6, J is 3. So number of dimensional number will be 3, right? So pi 1, repeating variable will be the flow parameters, that is rho, then the rotational speed, the flow characteristic, that is N. So it is A1 n to the power b1 and d to the power c1 p. Then pi 2 will be rho to the power a2 n to the power b2 d to the power c2. Then q, and pi 3 will be rho to the power a3 n to the power b3 and d to the power c3 is mu, right? Now if you just do the similar problem I have done in the first example of frictional resistance. So their unit will be a little bit different, but everything is same, right? So if you took these values, so you know that rho is ml to the power minus 3 revolution per second. It is only t to the power minus 1. D is L and P is the power. Power is force into velocity. Force is ml to the power minus 2 into velocity L into t to the power minus 1. So if you arrange this, so I am writing the first one, you do it yourself. Okay, practice it. Next problem I will just explain. I will not be. So pi 1 will be coming as, just cross check it. If you can't do it, let me know. I will do it for you in the next class or next time. Okay. So P can be coming as rho into the n cube d to the power 5. Pi 2 will be q by n d cube. Pi 3 will be rho n d square by mu. So this P by rho n cube d to the power 5 will be a function of q by n d cube into rho n d square by mu. I think as till now you have understood how to calculate these things, how to compare their unit, right? And how you are getting this, right? So do it. So capillary rise problem is also same. Next one. Sorry. Yeah. The height of to which a liquid rises in a small capillary tube depends on the tube diameter, the liquid density, the surface tension, and the acceleration due to gravity. So H is a function of tube diameter, D liquid density, rho surface tension, and acceleration of due to gravity. So here n equals to 5, j equals to 3. So number of dimensionless group will be 2. So pi 1 will be, repeating variable will be the flow property, which is density at above A1. Then the flow velocity, flow characteristics, which is the gravitational due to gravity, g to the power b1, and the diameter, that is d to the power c1. These are geometrical characteristics. It will be one with h, and the second number will be rho to the power a2, g to the power b2, d to the power c2 into sigma. So if you know all the unit expression, right? So finally it will come as pi 1 will come as only h by d, and pi 2 will come as sigma by rho g d square, which is called the bond number. If you calculate this, you will find it. Okay, so you can write h by d is a function of bond number, okay, which is suffocation force by gravitational force, right? Next question, the periodic time t of a simple pendulum is assumed to depend on the mass and the length and the acceleration due to gravity. Apply the theorem to find. So here t is a function of mass of the bob, length of the bob, and g. So n is 4, j is 3, pi is number of 1. So pi 1 will be, so there are 3 parameters. So it will be m to the power a, l to the power b, g to the power c into t, right? So if you compare all this, let me do it for you, the last one. So it will be m0, l0, t0 into m to the power a, right? L to the power b, g is l, t to the power minus 2 to the power c, and t is the periodic time, then again it is t, right? So m would be, if you compare m, it will get 0 equals to a. So a equals to 0. If you compare l, you will get 0 equals to b plus c, right? So 0 equals to b plus c, so b equals to minus c. And if you compare t, you will get 0 equals to minus 2c plus 1. 0 equals to minus 2c plus 1. So c will be half, and from here b will be minus half, right? So now you can write pi 1 will be m to the power 0, it doesn't survive, so L to the power b. So L to the power minus half, or you can write as root L, then, or 1 by root L, sorry, 1 by root L, root g to t. So it is basically the dimensional number coming as pi1 equals to t into root g by L, right? So this is your answer. So this is the last problem. I hope you have understood this. The second last and third last problem, I have not done it fully because I have left it for you to solve, to compare. Just everything I have done, only I have given the expression only just to compare and check that whether this expression is coming, or not, this one, and from here this expression is coming or not. Okay, this expression, just cross check it. That is why I have left it, so you have something to do. Otherwise I have done everything in this class. This expression, and just compare the unit, power of the unit, basic parameters. Okay, so these two you cross check it. The third one I have done, it has only one dimensional number. I hope you have understood how to calculate the Buckingham pi, the non-dimensional number, using Buckingham pi theorem and both the Rayleigh method, and also some problems we have seen about the similitude. Okay, dynamic similarity. So if you have any question, I will uploading this lecture tonight. So if you have any question from this lecture or previous lecture which has already been uploaded in the YouTube, please feel free to ask. Okay, we'll meet on the next week. Till then, goodbye.